I hope all are safe at home, children. You are having a good time with your family members during this quarantine period, and your parents are preparing delicious food during this period. And I hope you are also helping them. And whenever we are going out during this period, we are advised to wear face mask. And there are of many types of face masks you might have heard, and one of the types is N95. And you know it is made up of what? It is made up of polypropylene. Again, poly means polymers. It is a polymer of propylene, and it is a surgical mask. So polymers are the backbone of modern civilization. In almost all walks of life, these polymers are extensively used. And here you can see some pictures: fertilizers, cosmetics, carpeting, adhesive, fabric, plastics, rubber, paints, everything polymers, automobile parts, tires, gears, seals, and electrical insulating material, polyvinyl chloride, PVC pipes, machine parts, biochemical and surgical equipments have completely revolutionized our daily life and industrial scenario. In fact, these polymers are the backbone of four major chemical industries, that is plastic industry, elastomers, fibers, paints and varnishes. So today we discuss the topic polymers. Today we discuss about the 15th unit, polymers. In this unit, you discuss about the definition of polymers, then what is homopolymer and copolymer, then classification of polymers, then types of polymerization, and then rubbers, then biodegradable polymers and their applications. And these things we discuss today. First we discuss what is polymer. From the word you can understand what is polymer. Poly means many and mer means parts. It is actually, the term is derived from two Greek words. Poly means many and mer means parts or units. Here I have written the definition. So polymers means they are the very high molecular mass substances which consists of a very large number of simple repeating structural units joined together through covalent bonds. So polymers means they are high molecular mass substances. Their molecular mass range is 10 to the power 3 to 10 to the power 7 U. U means unified mass. So they are macromolecules. They are not micromolecules. They are macromolecules. And the repeating simple structural unit is called monomers. Please underline. So what is monomer? And monomers converted into polymers is called polymerization. And some examples of polymers, many you can give: polythene, PVC, plastics, rubber, etc. And now we discuss about how it is classified into two categories. Depending upon the nature of the structural unit, polymers are divided into two categories. One is homopolymer, another is copolymer. What is homopolymer? Polymers whose repeating structural units are derived from only one type of monomer. Then it is called homopolymer. Example, you take CH2 double bond CH2. You are familiar with this compound, that is ethene or ethylene, we say common name. Ethene polymerization, it gives polyethene. It is an example for homopolymer. Other examples are polyvinyl chloride, Teflon, PAN. PAN means polyacrylonitrile, polypropane, etc. Copolymers means the polymers whose repeating structural units are derived from two or more different monomeric units. Then it is called copolymers. If the polymerization involves 2 or more monomer units, it is called copolymer. Example, nylon 2,6. How it is obtained? It is obtained from hexamethylene diamine and adipic acid. The formula I have written NH2, CH2 6 times, NH2 plus COOH, CH2 4 times COOH. Adipic acid. This polymerizes and gives nylon 2,6. It is coming under copolymer. Other examples are Buna S, Buna N and polyesters. Polyesters. And Buna N and what is Buna N and what is Buna S, that we discuss later. I hope you understood this homopolymer, copolymer, and what is polymer and what is monomer and what is polymerization. Here I have given again the definition for polymers. Polymers are made up of large number of macromolecules, and the single unit of polymeric chain is called a monomer. And this process of formation of polymers from their respective monomers is called polymerization. Example I given already, ethene polymerizes and gives polyethene, and hexamethylene diamine plus adipic acid polymerization, you get nylon 6,6. Now I tell you how to write the polymerization reaction. Just I write here, you see, concentrate. How to write the polymerization reaction? First you should write the monomer. Suppose I take ethene. And this n times you have to take, because polymer means we need many parts. So that's why n may be 1000 or 2000 like that. So n number of ethene is taken. Above an arrow you have to write P. P means polymerizes. And it gives the polymer, double bond is removed and it is extended both the side, and you have to write n times here. It is polyethene. This is the way you have to write your polymerization reaction. And here it is extended because everywhere you have to see the tetravalency of carbon, whether it is satisfied or not. You should not put double bond here. Double bond is removed and this unit is repeated and it is added, and finally you get polyethene. Second example given in this slide, I given already hexamethylene diamine. Hexamethylene diamine. It is one monomer, and this polymerizes. This will combine with adipic acid. It is a copolymer, again n times, so it is adipic acid. What is the IUPAC name? You can guess here. 2 COH groups are there. It is a dioic acid, and total 6 carbon atoms are there. It is a hexane 1,6 dioic acid. Okay. So now these two monomeric units condenses, that is polymerized, and gives the polymer, that is nylon 6,6. How I am writing, you see, condensation occurs between two functional groups are there in both the monomeric units, and you get NH2. This is the way you have to write your polymerization reaction 6 times, and NH, H is removed, and here OH is removed from this COOH, and you get CH2 4 times, CO n times. So, and the line should be extended both the side, and this is nylon 6,6. I hope you understood how to write this polymerization reaction. I have given ethene, it gives polyethene, and 2 monomers. This is homopolymer, only one monomer is involved, and here it is copolymer. How to write only, just I have mentioned here. Both the side it should be extended. This is the way you have to write your polymerization reaction. So anything given, you can write the same manner. Now we discuss classification of polymers, how they are classified. You can classify the polymers in many ways. First way is given here. This is the classification of polymer. based on the source of availability, whether we get from nature or whether fully we synthesize or partially we get from nature, then we modify in lab. So first classification is based on the source of availability of the polymers. So based on that, they are classified into three types. First one is natural polymers. Natural polymers means these polymers are found in plants and animals. We get from nature. Examples: protein, cellulose, starch, resins and rubber. Such polymers we call it as natural polymers. Second is semi-synthetic polymers. Cellulose derivatives as cellulose acetate, that is rayon, and cellulose nitrate, etc. are the usual examples of this category. Actually, they are derived from nature but modified chemically. It is called semi-synthetic polymers. The third type is synthetic polymers. Synthetic polymers means man-made polymers. Fully we make in lab. A variety of synthetic polymers as plastic, that is polythene, synthetic fibers, that is nylon 6,6, and synthetic rubbers, Buna S, are the examples of man-made polymers. They are extensively used in daily life as well as in industry. So this classification is based on the source of availability. So natural polymers, semi-synthetic polymers and synthetic polymers. Second classification based on the structure. They are classified into three types actually. The first type is linear polymer. Linear polymers on structure. These polymers consist of a long and straight chains. You can see this. This is a one polymeric chain. This is another polymeric chain. So they are long and straight polymeric chains. And the examples of these polymers are high density polyethylene, polyvinyl chloride, and the diagram is given here. And the monomeric units are joined together to form a long straight chains of polymers. So polymeric chains, they are arranged in a linear way. Second is branched chain polymers. These polymers contain linear chains having some branches here and there. You can see the branches. Here one branch is there, here one branch, and here one branch. So the monomers not only combine to produce the linear chain but also form branches of different lengths. Such polymers we call it as branched chain polymers. Example, LDPE. LDPE means low density polyethylene. But here high density polyethylene, here low density polyethylene. And 1 year board question they asked which is linear type. So high density polyethylene or low density polyethylene. High density polyethylene is a linear polymer and low density polyethylene is a branched chain polymer. So here L is there and here L is there. So L will not come for L. You can remember easily. Branched means low density polyethylene. And for branched chain polymers, the other examples are amylopectin and glycogen. The third type is cross-linked or network polymers. And these are usually formed from bifunctional and trifunctional monomers and contain strong covalent bonds between the various linear polymeric chains. So you can see here few cross-link is there between the polymeric chains. Example, bakelite and melamine formaldehyde, etc. And the diagram is given here. They are hard, they are rigid, and they are linear polymeric chains joined together to form a three-dimensional network, and cross links are there here and there, and they form a giant molecule. This is the structure, and this is polymeric chain, and then and there cross links are there. They are called cross-linked polymers or network polymers. So example, bakelite, melamine formaldehyde, even urea formaldehyde, many examples you can give. I hope you understood this classification of polymers. So two classifications we discussed. Next is the classification of polymers based on the mode of polymerization, whether the monomeric units are added or they are condensed. So based on that, the polymers are classified into two types. One is addition polymerization, another is condensation polymerization. First we discuss addition polymers. What are addition polymers? Addition polymers are formed from the repeated units of monomeric units possessing double bond and triple bond. Please underline this point. Addition polymers are formed by the repeated addition of a large number of same or different monomers possessing double bond or triple bond. Again I repeat, addition polymers are formed by the repeated addition of a large number of same or different monomers possessing double bond and or triple bond. The polymers formed by the addition of two different polymers are called copolymers, and the same monomer is the repeated, then it is called homopolymer. Here examples are given. So homopolymerization is also there. Here also copolymers also there. And both are coming under addition. So addition means double bond or triple bond will be there in the monomeric units. Now examples given. You take addition polymers coming under homopolymer category. Ethene, that is CH2 double bond CH2 polymerizes and gives polyethene, and you get addition polymer. The polymers made of addition polymerization from two different monomers are termed as copolymer. Example, Buna S and Buna N. The reaction given here is Buna S. What is Buna S? From the word you can guess the monomeric units. Bu means butadiene, 1,3-butadiene. Diene means double bond is there. And Na means sodium. Actually here sodium is acting as a catalyst. And S means styrene. C6H5, CH double bond CH2 and polymerizes and gives butadiene styrene copolymer. The reaction is given. Addition polymers, again based on the mode of polymerization, polymers are classified into two types. One is addition polymer. How to write this addition polymer? Again I am explaining. Ethene, N number, polymerizes and gives polyethene. You have to extend both the side and n times you have to write. This is polyethene and this is ethene. Monomer is ethene and polymer is polyethene. And it is a which category? Homopolymer. Because only one monomeric unit is involved. Second example given here is Buna S. Second example is Buna S. Bu means 1,3 butadiene. And Na means sodium, catalyst. And S means styrene. So what is butadiene? I am drawing the structure. CH2 double bond CH, CH double bond CH2. You can number the carbon also. After the first carbon double bond is there, after the third carbon, that's why it is 1,3-butadiene. 4 carbon atoms are there. And styrene, the structure is CH double bond CH2 in ethene. One benzene ring is there. Or instead of this ring, you can write even C6H5 also. C6H5, CH double bond CH2. Now, this polymerizes and double bond is shifted to the middle. So, how I am writing, you see, CH2 extended, CH, here double bond is formed and CH, CH2. And this is combined with this monomer, it is extended n times. This is called Buna S. I hope you understood this addition polymer. It is coming under which category? Homopolymer. Addition polymers, two examples I have given. One is polyethene. Second one is Buna S. Polyethene is coming under homopolymer And Buna is, by mistake I told homo, it is a copolymer. Next, coming to the condensation polymers. Condensation polymers are formed by the repeated condensation reaction between two different bifunctional or trifunctional monomeric units. In these polymerization reactions, the elimination of small molecules such as water, alcohol, hydrogen chloride, etc. take place. What is condensation polymerization? They are formed by the repeated condensation between two bifunctional or trifunctional monomeric units with the elimination of small molecules like water, alcohol, hydrogen chloride, etc. The examples of this condensation polymers are given here are nylon 66 and nylon 6. And here nylon 66, two different monomers are involved, so it is a copolymer. And a nylon 6, only one monomeric unit is involved, it is a homopolymer. So two examples given. First I write nylon 66. Condensation polymers. Here two examples given. One is nylon 66, another is nylon 6. It is a copolymer. Both the cases condensation occurs. It is a homopolymer. Now I write how you get this nylon 66. It is obtained from NH2, CH2 6 times NH2. This is nothing but hexamethylene diamine, and this condenses with adipic acid. Adipic acid. So two different monomers are involved here. Here condensation occurs between amino group and carboxylic acid group, and water is released during this process. Polymerization, N number, this also N number, and condensation occurs between amino group of one monomer with the carboxylic group of another monomer, and water is released, and here hydrogen is removed and here OH is removed and water is removed, and finally what you get will be, this is extended this side, CH2 6 times NH, CO, CH2 4 times, and this side also it condenses with another hexamethylene diamine and forming a polymer. This is called nylon 66. Why? Because two monomeric units have how many carbon atoms? 6 carbon atoms. So that's why it's called nylon 66, and it is a condensation polymer. Condensation, here water is removed. So two monomeric units condenses with the release of water molecule, and two different monomers, that's why it is copolymer. And nylon 6, it is obtained from aminocaproic acid that contains how many carbon atoms? 6 carbon atoms. 6, 5 plus 1, 6. That's why it is nylon 6. And here also this condenses with another molecule and forming a polymer. Which way you have to write the polymeric structure? I told already. And here OH is removed, it condenses with another molecule of aminocaproic acid. This condenses with another molecule of aminocaproic acid, and finally what you get will be nylon 6. It is a homopolymer. I hope you understood this condensation polymerization. So based on the mode of polymerization, polymers are classified into addition polymers and condensation polymers. Addition polymers are formed by the repeated addition of a large number of same or different monomers possessing double bond or triple bond, and condensation polymers are formed by the repeated condensation between two bifunctional or trifunctional monomeric units with the elimination of small molecules like water, alcohol, hydrogen chloride, etc.